All right, here we go again. This is the new material for this week with our trig functions. So now we've talked about what a trig ratio is when we're relating the two sides. Then we talked about what to do if we're missing an angle measure, but now what do we do if we're missing a side measure? Great question. Important thing to think about today is that you're always going to need two pieces of information and you'll always be able to solve for a third piece. So before we would have something that looked like this example 1 here. We have 7, we know that's one of the legs, we have 25, that's our hypotenuse, and we're missing another side. So if you have two sides of a right triangle, you can always find the third using that Pythagorean theorem we've talked about a lot this year. So without even talking about trig functions, we can use Pythagorean theorem, which is our a squared plus b squared equals c squared. The only really important thing is that our c squared is always the hypotenuse. Doesn't matter if I make a 7 or if I make b 7. So in this case, I'm going to do 7 squared plus x squared equals 25 squared. So we end up with 49 plus x squared equals 25 squared, 625. I'm going to subtract 49 from both sides. That's our inverse operation of addition. So I have x squared equals 576. So that's what our x squared is. So to undo x squared, I have to take that square root to cancel out that squared. I'm left with x equals, square root of 576 is 24. Easy enough. That's using review. That's using things that we've been using all year in geometry. We know that we can always use Pythagorean theorem when there are right triangles. So keep that in mind. Even with trig, when you have two of the sides, you can always find the third using Pythagorean theorem. So we're going to be using that a lot today. Now, example 2 is going to be using a little more trig because we're not necessarily given two sides in this case. We're given an angle of 32 degrees, and we know that 17 is one of our sides. But that's all we really know. So we're looking for theta, x, and y. And when we're doing this, we can really start wherever we want, but I'm just going to start with theta because it's first here. Theta is another angle. Now, we should hopefully remember that all triangles have the same, they add up to the same thing on the inside. Our interior angle sum of a triangle is always 180 degrees. So if we know this guy's 90, we know this guy's 32, I can figure out the last one by doing 180 minus 32 minus 90, and we are left with 58 degrees. Easy enough, and I'm going to write that in here so we can maybe use it later. Alright, so now we know 58 degrees. Then we're looking for x. X is this guy down here. I'm going to use a different color here. I want to look at my 32 degrees and use that as my main angle because that's the one I know for sure. What if I made a mistake figuring out that 58 degrees? I don't want to use my mistake to figure other things out later. So I'm going to use what I know for certain. That angle is 32 degrees. Now I'm going to label my sides. We have 42, or the 17 here, that's opposite of that 32 degrees. We have my adjacent of x, and we have my hypotenuse of y. So I'm going to write SOHCAHTOA down here just so I have that reference. Now, if I'm looking for x here, that's an adjacent to my 32. And I know this 17 here is an opposite. So opposite and adjacent, I'm going to end up using tangent here. So I know my tangent of 32 is equal to the opposite over the adjacent. Now, this is tough because I don't know what x is and it's on the bottom. So first things first, I want to get that x out of the denominator of this fraction and get it by itself. I'm trying to solve for x here because that's what I want to know. So it's in the denominator, it's being divided. So I'm going to multiply both sides by x to get that out of the denominator. So then I have x times the tangent of 32 equals 17. Okay, I'm getting there. I need to get x by itself still, and right now this tangent 32 is making it not by itself. So since it's being multiplied, I want to do the inverse operation of multiplication, and I'm going to divide by the tangent of 32. And what I do to one side, I have to do to the other. So those cancel out. I'm left with x is equal to 17 divided by the tangent of 32 degrees. So that I can actually type right in my calculator. I do 17 divided by tangent of 32, and I end up with 27.2. That is my side measure for x. I'm going to write that there. Again, I might be able to use that later. So now I'm looking for y, which is my hypotenuse here. And if I'm looking for that, I could, if I wanted to, use the Pythagorean Theorem and do 17 squared plus 27.2 squared equals y squared, and then solve for that. But because I found this 27.2 and there's a chance that I made a mistake, I'm not going to use that today. What I'm going to do is I'm going to look at this 32 again, and I still know my opposite is 17, my adjacent is x, my hypotenuse is y. But this case, I'm looking at my 17 and I'm looking at my y as opposite and hypotenuse. So if I look down here and I want to look at my opposite and hypotenuse, that has to do with sine. So I'm going to use the sine of 32 equals opposite over hypotenuse. And now it's the same concept as what we just did with solving for x, except we have a y in the denominator this time. So I'm going to get it out of the denominator by multiplying by y. What I do to one side, I have to do the other. Then I'm left with y times sine of 32 equals 17. I don't want this sine 32 with my y, so I have to divide it on both sides. Those cancel each other out. And y is going to be equal to 17 divided by sine 32. And I can type that in my calculator, and I end up with 32.1. Awesome. So now I've figured out all my sides. I've figured out all my angles, and as you can see, we can always check our work. Our hypotenuse should be the longest side, so that 32.1 is bigger than 27.2 and 17, so we're probably right. All right, so we'll come back later and I'll give you another example and we can get practicing on this.